So to continue with the central nervous system, we're going to talk a little bit about some deeper stuff. Systems that are within the brain. So these are networks of neurons that span areas of the brain, and they have a job to do. They work together. And the two major ones are the limbic system and the reticular formation. Now, the limbic system is kind of in the diencephalon and surrounds the diencephalon. There's a lot of connection to the cerebral cortex through the cingulate gyrus. There and down into the temporal lobes. But this is really the emotional part of the brain. This affective means emotion. So this is the part of the brain that lets you interact emotionally with the outside world. So the amygdala is all about fight and flight. It's about recognizing threats. Its job is to process and perceive threats before they happen. It's a protective mechanism. So it helps you assess dangers. It elicits fear. It recognizes angry faces, facial expressions on other people. Look, you all know people that are ignoring their amygdala. When you're really pissed off and you give them that look and they just freaking continue anyways, they don't realize the danger. So that's their amygdala failing them. So the amygdala is all about imagining the fear. It's what works at Halloween when you go down to Canada's Wonderland, to Fear Fest, things like that. It's even though you consciously know that it's safe, your amygdala tells you that it's not. Right? It's the one that it's the part of the brain that lets you hear the boogeyman in the rustling of leaves or the blowing of wind, that kind of thing. A strong amygdala is a very important asset to the evolution of humanity. People that our ancestors that didn't have an amygdala probably got themselves into dangerous situations and ended up being some animal's lunch, and instead of our forefathers. Now, the cingulate gyrus is that last gyrus that surrounds the limbic system and is part of the cerebral cortex, and it's involved with the other side of this. This is how you express emotions. This is how you gesture. So this is what makes you smile or makes you grimace or things like that. It causes complex gestures, and it also is involved with resolving mental conflict. So when you're kind of told two things, it helps you resolve it. Your olfaction goes directly into the limbic system, and so there's emotional responses to odors. I've already kind of alluded to this. This is why if you're trying to sell a house, you bake cookies. This is why those of you who are parents in the room know that your baby is the best smell in the world. There's an emotional response to that smell. I figure you could make $1 billion if you could figure out how to capture the scent of specific babies and then sell that to the parents later. So this limbic system interacts in the prefrontal cortex, and so that we can react emotionally to what's going on. It makes us aware of our emotional lives. Like when you're in love, it makes you aware of it. It makes you seek out more of that. It's what makes you laugh, or what makes you happy. It's what makes you fearful. When you see something going on, it's what makes you have an emotional response to it. And emotional responses are very strong things, and they're hugely responsible for creating memory. Something that creates an amygdala response, or even that, for that matter, hippocampus response, will make you remember it. You don't have to be attacked by a tiger twice for you to understand that maybe you should avoid a tiger if you see him in the wild. That's what it's about. It's helps us create memories, and the stronger the limbic response, the stronger the memory is. It's one of the reasons why the inappropriate poems help you remember the carpal bones, because it creates an emotional response that commits that thing to memory right away. Unlike a poem or a saying that doesn't create an emotional response, that you don't find funny or gross or inappropriate. Okay, the reticular formation is the next group here, and there's columns. They run along the brainstem. They connect to the hypothalamus, the thalamus, the cerebellum, to the spinal cord. There's various groups of cells called nuclei, medial, lateral, and raphe. And it's involved with focus and making you alert. Now, there is something called the reticular activating system, and it makes you alert or conscious. It's what would be termed engaged, or engagement, is what the job of the RAS is. It filters out crap that isn't deemed appropriate, or the stimuli is too weak or too repetitive. This is where consciousness seems to be residing, because when it's damaged, you're unconscious, you're in a coma. So it's got something to do with being awake and alert and conscious. Right? It's involved with respiratory centers and cardiac centers and cardiovascular centers, limb movements, that kind of thing. And it seems to go to everywhere in the brain. Okay, so we're not going to talk too much about electroencephalograms. These are the EEGs. It's really a measure of electrical activity in the brain. And so it's really a matter of how many action potentials are happening in neurons, because those are electrical events. And so, the leads go on. And if you're interested in it, you can read about it and look at brain waves and such, the different types of brain waves. Um, you know, Probably clinical death, brain dead, is when you have a flat EEG. There's no brain waves. This epilepsy is, we won't talk about because that's a pathology. And so again, but we will talk about consciousness. So conscious is being aware. You have perception of your sensations, that you have voluntary control of things, right? This is really nebulous, but you have memory and logic and judgment. And so this is the way we know that your brain is functioning, because when you lose those things, you have a loss of consciousness. So there's a continuum of consciousness. So you are alert, which is hopefully what you are as you're listening to this, but you might be lapsing into drowsiness or lethargy. This is where you get sleepy and your attention lapses. The reticular, the RAS, the reticular activating system, isn't functioning completely. Your mind wanders, you're just sleepy and drowsy. Stupor is when you are literally falling asleep. This is when you can't arouse a drunk. He's in a state of stupor. And then when you don't respond to any stimuli at all, it's considered a coma. So in psych, you guys talked about sleep. So this is partial unconsciousness. But people can be aroused by stimulation. So really, what sleep is kind of a temporary cessation of the RAS, but stimulation then turns the RAS on and the reticular system arouses and you're back to conscious. There seems to be a couple of different sleep patterns. There's the non-rapid eye movement and the REM sleep, the rapid eye movement sleep. So it goes through stages. There's 4 stages of non-rapid eye movement, and you kind of go through them, and then, an hour and a half into it, you get through the 4th stage, and then you end up in rapid eye movement. This is where dreaming happens. This is deep sleep. There's a lot of evidence that says that people with sleep apnea and things like that never make it into these stages. One of the problems is that you can't just go back and forth from the 4th stage into REM very easily. You pretty much, if you're aroused, have to go back through all the stages. So this is a nice little chart. So in non-REM relaxation, this is where you start to doze off. This is where arousal is really easy. This is the stage you get when the commercials are on. You want to stay awake to watch the rest of the show, but the commercial comes on and you slip into kind of this stage 1. Stage 2 is where it's more difficult to arouse. So little noises and things don't bring you out of it. Stage 3 is a little deeper, and this is where your vital signs start to change and slow down. Stage 4 is when you're in a deep sleep. This is when arousal is very difficult, and this is when sleepwalking occurs, if people are stuck in this stage 4, or night terrors or things like that. They don't wake up to normal stimuli, noises or things like that. Then REM sleep is all your skeletal muscles are inhibited except for your breathing and the muscles of your eyeballs. So that's why it seems that your eyes move so much. This is where dreaming happens. There is a pretty good theory that growth hormone is released during this, and this people that don't make it into REM sleep tend to have problems with fibromyalgia and such. But that's a topic of a whole different discussion. So the RAS is inhibited during sleep, and we kind of cycle between REM and non-REM sleep as we go through it. So this would be a progression of through a night's sleep. So you're awake, you kind of go in and out. We don't know what sleep is really for, but it could be that this is where we process and create memories and kind of purge information that's not important. So sleep disorders are pathologies, etc. So we're just going to stop this kind of right here till we get down to memory. Now, memory is an interesting thing, and we create memories. There's a type of memory called declarative memory. This is factual knowledge. This is explicit, and this is long-term memory, and this is just facts. This is kind of cue card learning. This is declarative. I can declare that the world is round, or that kind of thing. Just these are facts that people make. There's non-declarative memory. This is procedural memory. This is motor memory. This is what you get through experience. This is the hands-on learning. This is like you can read about how to fix a motor, but until you actually fix a motor, you don't really understand it. And so this is it's kind of less declarative, it's less factual, and more kind of experiential memory. This is probably the better kind of memory because you don't mix it up. There seems to be another kind of memory, which is locative memory, and locative memory is where you store things. There's a good school of thought that says that the current generation is much better at locative memory than it is at declarative memory, because really with the internet and smartphones and things, you basically really only have to know how to find out information. You don't need to really store the information itself. You need to store the location of the information. So I'm not going to get into the hippocampus and all of that, but it seems that there are circuits within the brain that help bring all of this together. So there's emotional memory, motor memory, procedural memory, and so on. The rest of these slides on memory are very complex and not really that important. So really this is, how are memories physically made? So it really is increasing the number and the size of the presynaptic terminals by releasing more neurotransmitters, by creating more synapses. Memories are stored. It really is about making connections. Like, you really don't care that glutamate binds to NMDA receptors and calcium channels open and blah, blah, blah. And gene activity and all of this really is more complex than we need at this level, at the level of this course.